Good afternoon, everyone. Myself, Juli Yadav, Assistant Professor in Computer Science and Engineering Department from AKGEC Engineering College, Ghaziabad. So today's topic of presentation is Introduction to Searching Algorithm in Artificial Intelligence. So what does this, why we need for the searching algorithm? Because of finding the solution for the problems. What does the problem is? A problem is defined by its elements and the relation between those elements. So to build a system to solve a particular problem, we need to do 5 things, or we can say there are 5 approaches to solve a problem. So the first approach or first step is to define a problem. Before solving any kind of problem, firstly we have to understand and we have to define what kind of problem it is. So there is a need of defining a problem. That is the first step of solving a problem in AI. So defining a problem means whenever there is a problem arise, then the agent must first define a problem to an extent so that a particular state space can be represented through it. Means if there is a problem, then we have to define that problem in a depth so that we can get to know what are the states that come in the problem. So then we can analyzing and defining the problem is a very important step, because if the problem is understood sometime which is different than the actual problem, sometimes there is a dilemma that the requirement is something else and what we understand is something else. So there is a need to define a problem in a depth. Then the whole problem solving approach that has to be followed by the agent is of no use if the problem that we are understanding is different from the problem that the agent is designed for. So the second step is, after defining a problem, then we have to form a state space. State space means we have to convert that problem statement into state space. State space is a collection of all the possible valid states that an agent can reside in. Means there are many possible conditions or possible states. Suppose if I'm standing here and my problem is to go out of this studio, then what are the states? First state is I have to take my step outside this studio. Then another state is I have to open the door. Another state is I take all my accessories. Then another step is open the door. So these are the states that need to be followed to reach to the goal. So while a problem has been defined, then there is a need of state space diagram. So here all possible states are chosen which can exist according to the current problem. The states are according to the problem. So the rest are ignored while dealing with the particular problem. If there are n number of states and we have to follow or we have to choose those states that takes us to the solution or that takes us to the conclusion for that particular problem. So this is the second step or second approach that need to be followed to solve a particular AI problem. Now the third approach is gather knowledge. After we have defined the state space, that before doing the next step, what step we should follow, then we have to collect or we have to gather the knowledge. If knowledge is related to what kind of steps or what kind of experience or what kind of knowledge we have to solve that particular problem. So basically, we have to collect and isolate the knowledge which is required by the agent to solve the current problem. There is a problem, then we need to solve that problem by using the artificial intelligent agent. So there is a need of the knowledge. If an agent does not have any knowledge, then how can it be solve the problem? So there is a need of gathering the knowledge from different areas. Like we can gather the knowledge is done from the pre-embedded knowledge in the system and the knowledge it has gathered through the past experience. It means the process that we have used for representing the knowledge, that is also needed, as well as the knowledge that the agent has gathered from the past experience in solving the same problem earlier. So these are the 3 steps. Another step is planning. Now we have to plan the data structure that needs to be used, or we have to plan the strategy that are to be taken to solve that particular problem. So a problem may not always be an isolated problem. It has various related problems as well. So we need to know about the related areas from where the decision made is to be needed to reach the current area. So as a well-suited data structure and a relevant control strategy must be decided before attempting to solve the problem. So if you are trying to solve the problem, you have to plan each and everything, that you are designing an agent for that particular problem, what steps it has to be followed to solve this particular problem. For example, we have taken in the previous presentation the example of a vacuum cleaner, how it functions, how it works, that need to be planned. So there is a need of planning to solve the AI problem. Now the last step is applying and executing the plan or planning that we have done to solve a particular problem. After the gathering of knowledge and planning the strategies, the knowledge should be applied and the plan should be executed in a systematic way, so as we can reach from current state to the goal state in a most efficient and fruitful manner. Means after collecting and gathering all the knowledges and planning what we have to do, what steps we have to follow, then we have to execute them by applying those knowledge, those strategies to reach from current state to the next state, or you can say the goal state, the problem that has been defined to solve that particular problem. So to find up any kind of problem, to solve any particular AI problem, we need to follow all the 5 approaches that have just explained. So there are 2 ways in which the AI problem can be represented. I have just told you state space representation. So there are 2 ways in which you can represent the problem. As you have defined the problem, now you have to represent it. So there are 2 ways. First one is the state space representation. Another one is the problem reduction. So let us understand what is the state space representation. State space representation consists of defining an initial state. Means we have to define the initial state and the goal state. Initial state is the state from where we have to start solving that particular problem, and goal state is the solution of that particular problem. Then we need to follow the certain sequence of steps that are called as states. So let us define each of them separately. So AI problem can be represented as a well-formed set of possible states. States can be initial state, that is the starting point, goal state, that is the destination point, or there are so many possible intermediate states that you need to be followed to reach to the goal state. So state I have already defined. Now the another term is the space. In an AI problem, the exhaustive set of all possible states is called space. Means the possible state means there are n number of states that you need to follow, or there are many other states also that you know that these states can also be used, but you didn't explore them or you didn't reach them. So combination of all those states that you are following and the states that you are not following makes a state. So another term is search. In simple words, searching is a technique which takes the initial state to the goal state after applying so many valid rules while moving from space to all the possible states. So there are 3 possible states. First one is the initial state. Then we need to follow the set of rules that need to be followed to reach to the goal state and the goal state. So these 3 things need to be known while we are doing the searching operation. So probably this whole is known as the state space representation for any kind of problem. So here you can see S is the S, A, action of S, result. Here S is the source from where the it is the state from where you have starting the from where you have start exploring the problem. Then A is action that you need to be or you can say the next state that you need to be reached. Action on S, it means if you are on the current state S, then what action did you follow to reach to the next state? For example, 8 puzzle game, we can take only 4 actions, that is moving left, moving right, moving up and moving down. So those are the actions. Action of S is the action applied on that particular state to reach to the next state. Result of S comma A, it means if you are applying action of moving right, then on particular or on that particular state, if you are applying the action like moving right, then what result it will make, means what state we will get, that comes under the result of S comma A. And cost of S comma A is the amount or the cost that is to be needed to reach from state S to another state by taking an action A. So this is the state space representation. This is the way how we can find the state space representation. Now here is the example of a chess game. The initial position of all the pieces on the chessboard define the initial state. When we are start playing the game, we have placed all the chess components in the chessboard. Then that state is known as the initial state. That there are many number of rules for playing the chess game. So we have to define the set of legal rules. Then we have to define the goal state by any possible board position corresponding to a draw state. So the point that need to be noted is that there can be more than one goal states. There can be more than one goal states. So there can be more than one possible path that you need to be followed to reach to the goal state. So this is another example of tic-tac-toe game. It is a kind of problem, or it is a game that you have to represent as a state space representation. So the starting from the initial state, as we move on applying rules of putting in tic-tac-toe game, what we have to do, there is a board on which you have to mark X or cross and 0, and then you have to follow certain rules, and then you have to find if there is this kind of condition. Our goal is what? Our goal is to make a win state, this kind or this kind of state, or this kind of state, or this kind of state. So in this game, you have to win while there is while the symbols on the column is same, then you can win. While the row they are same, or diagonally if they are same, then you can say you are the winner. So there are possible states that need to be followed, or there are many possible states that can come under while you are finding the solution, or while we are drawing this solution for that tic-tac-toe game. So the new state is generally generated from the earlier one by applying the control strategy. Another problem is water jug problem. In this problem, this is one of the main or we can say the popular problem in artificial intelligence. In this problem, the problem is we are giving two jugs, one with the capacity of 3 liter, another with the capacity of 4 liter, and our problem is we have to fill the jug with the capacity of 2 liter, the jug which has the capacity of 4 liter with 2 liter of water. And the main problem is that there is no measuring mark on any of the jug, whether this if you have filled the half, then it means that this is the 2 liter or the 3 liter or the 4 liter. So there is no measuring scale on any of the jug. So the goal is, so the agent task here is to fill the 4 liter of jug with 2 liter of water by using only these two jugs. There is no any other external material is needed to fill both the jugs. So initially you can fill both the jugs. So this problem can be, this is the problem basically. Here we have jug A with 4 liter capacity, jug B with 3 liter capacity, and the problem is we have to fill this jug with jug A with 2 liter of water, means like this. And the main problem is that there is no measuring scale on it. So how we can solve that particular? So finding the solution for that particular problem, there are some sort of assumptions that you need to follow. The first one is we can fill a jug from the pump, means we can fill the jug from the pump, we can pour the water out of the jug to the ground, we can pour the water from one jug to another jug, and there is no measurable design. These are certain assumptions. So this is there are two solutions by which you can fill 2 liter of water in 4 liter of jug. So the first solution is, initially both the jugs were empty and we filled the jug B with 3 liter of that has the capacity of 3 liter. We have filled that jug completely. Then we transfer that to the jug A. Then jug B is empty. Then again we fill the jug B. There is 3 of 3, means jug A has the 3 liter water and jug B has 3 liter of water. Then we transfer 1 liter. There is no measuring. We know that jug A has the capacity of 4 liter. So we transfer 1 liter to jug A and then the remaining is 2 liter. So we pour the water from jug A and fill this 2 liter of water in jug A. So this one is the solution, and there is another solution for that particular problem is that initially we fill both the jugs. Then we fill the jug with 4 liter capacity. Then we transfer the water from jug A to the jug B, means here there is only 1 liter left, and we filled the jug B completely, that has the capacity of 3 liter. Then we pour out that water, and then again we pour that water, and the leftover water in jug A is transferred to jug B. Now we again fill the jug A completely, that is 4, and here is 1. We transfer that 2 liter of water from jug B, and here is the remaining. So the final state is 2, 0. This represent complete 2 liter water in jug A. Water in jug A. So these two are the solutions for filling a 4 liter of capacity jug with 2 liter of water without any measuring scale on it. So these are the production rules that we need to follow to solve the water jug problem that I have already explained. You can go through with this also. It's the time to introduce the searching algorithm that we need or that we are using while we are finding the problems in artificial intelligence. So to solve those problems, we need some sort of searching algorithms. So what this searching algorithm means? Artificial intelligence is basically the replication of human intelligence through computers or machines. Basically, artificial intelligence is similar to humans, means as the human thing, we want artificial object to be think in the same way. So it is done through the process of acquisition of knowledge and information, and in addition with some sort of rules that are to be used while we are forming when we are learning and using those rules to derive a conclusion, then we have to correct ourselves in that cases. So this we need to know. These are the properties of searching algorithm. We can use any of the search algorithm, but those algorithms need to be follow these properties. First one is the completeness. An algorithm is complete when it returns a solution for any input. Means if there is a solution for any input, at least one solution for any input, then we can say that algorithm is complete. Optimal is if the solution reduced by the algorithm is the best solution, means there are number of solutions and we get the best solution from that algorithm, then we can say that that algorithm is optimal. Now the time and space complexity. If an algorithm uses less time to solve the particular problem and uses less space to solve that particular problem, then we can say that the space and time complexity of that algorithm is less. So there are basically two searching techniques that we are using. First one is uninformed, or we can say it is the blind search, and another one is informed search, that we used to say it as heuristic search. So the uninformed search does not contain any domain knowledge how we are close to our goal node. Means in uninformed, as the word says, blind search means we don't have any knowledge about the closeness, means how much close we are to with our goal, means there is no knowledge of that. So we operate it in a brute force way, as it only include the information about how to traverse the tree and how to identify the leaf and goal nodes. We just only know how to traverse the tree, means we just know the techniques, how to traverse a tree and what are the nodes. We just know only about these. So this technique is applied in such a searching techniques where there is no information about the search space and initial operators. We don't have any knowledge about those, and we start searching the goal node using the blind search. So it examines each node of the tree until it achieves the goal node. So the another technique is the informed search technique, which is also known as the heuristic search. Basically, this technique uses domain knowledge, means while we are using the informed search technique, then there is some sort of knowledge that can help in finding the goal prior. So in an uninformed search problem, information is available which can guide us searching. Informed search techniques can find a solution more efficiently than uninformed, because in uninformed search we don't have any knowledge, any domain knowledge, and in informed search we have knowledge, so we can solve or we can find a problem earlier or in an efficient manner while we are using the informed search technique. Informed search technique is also known as heuristic search. Heuristic search is a way which might not only be guarantee for best solution, but guarantee to find a solution, good solution, is a reasonable time. Means heuristic search does not say that I'll provide you the best solution, but it can provide us a very good solution in a reasonable time. So informed search technique can be applied to the problems that are very complex and which cannot be solved in any other ways. So here are some of the uninformed search techniques, and here are some of the informed search techniques. So I will cover two techniques in this lecture or in this video. First one is the breadth first technique, and then uniform cost search technique, then depth first search technique, depth limited search technique, iterative deepening depth first search, and the bi-directional search. So I will give you a review on all these searching techniques, and in the next video I will upload about these informed search techniques. So what does this breadth first technique is? As from the word itself, we can identify the meaning of that searching technique. That breadth first search technique is basically used to search breadth wise. Means if these are the state space, if this is the state space and we are using the breadth first search technique, then how we can traverse this tree or this state space? While we are using the best first, then it searches from here, then it goes to here, then it goes to here, then it goes to here. So it searches basically breadth wise, or you can say level wise. If this is level 0, then this is level 1, then this is level 2. So we can say that it searches according to the level. It explores all the nodes which are on level 0, then it explores all the nodes which are on level 1, then further, and then so on. So BFS algorithm starts searching from the root node. As I have just told you that we have to start searching from here. So this is the root node from where we have to start the searching. Starting from the new root node, then it expands its successor nodes, or you can say that its child nodes from the current level before moving to the node of the next level. So this is the best example of general graph searching algorithm. Breadth first search, it uses FIFO. It uses Q data structure. Q data structure is based on FIFO. FIFO means first in, first out. The element that comes first has to be put in the list first, and it has to be taken out first also. So it uses the Q data structure that uses the FIFO implementation. So here are the advantages of BFS. BFS will provide a solution if any solution. It will definitely provide a solution if there is any solution. If there is more than one solution for a given problem, then BFS will provide the minimum solution which require at least few number of steps. If there are many number of solutions to that particular problem, then it will tell us the step or the solution that takes the minimum number of steps. These are the advantages. It requires lots of memory since each level of the tree must be saved into memory to expand the next level. If we want to know, if we are exploring this, then this node knowledge has to be stored somewhere in the list so that it can use it afterward, or while doing any sort of requirement, there is any requirement of the previous node, so that it can be retrieved from the memory. And it requires lots of time while we are finding the solution. If the goal node is, if we are traversing in this way and goal node is here, then it takes lots of time. So BFL algorithm has two categories of nodes. First one is the visited, another one is the non-visited. The purpose of algorithm is to mark each vertex as visited while avoiding cycle, so that there should be no cycle. It uses two categories. First one is the vertex and another visited, and another one is the non-visited node. So here we can see, this is the example of a graph that has 5 nodes, and here is the queue. Initially we have started from here, so that comes from 0 we have started, so 0 comes under the visited node. Only when you have placed all the successor nodes of zeros into the non-visited nodes. So these are the non-visited nodes, these are the visited nodes. So when we have kept the visited nodes, when we have kept the 0 as the visited nodes, then we can go to 1, we can go to 2, we can go to 3. So these are the unvisited nodes. So now we have 1 as in the front. So we have to explore 1. From 1 we can go to 2 and 3. So 1 we have already visited and 2 is already there. So 1 comes under the visited nodes. In the same way, when we reach to 2, because next node is 2, then 2 comes under the visited node. From 2 we can reach to 4. We have placed the 4 here. That comes under the non-visited node. And then 3, and 3 we can reach to 3 only by using 1 that has already been in the visited nodes. So here it is 4, and this one is the visited nodes. So in this way we have traversed the tree or the graph by using the best first search technique. So this is the another example. From, if we are traversing this and this is our goal node, we have to reach here. Then starting from S, then A, then B, then C, D, G, H, E, F, I, and then K. In this way we can traversing a graph or a tree. This is the solution, or this is the path that need to be followed to find the solution of this particular problem. So I will this is the time complexity of BD. This D is the depth and B is the branching factor. How many branches? Like here there are 2 branches, so B is that branch and D is the depth, in how depth that particular node is. So this is the time complexity. Space complexity is same as the time complexity. The completeness, BFS is complete, which means if the shallowest goal node is at some finite depth, then BFS can find the solution. BFS is optimal if path cost is non-decreasing function of the depth of the node. So I will discuss rest of the searching techniques in the next video. Thank you.